Hey everyone! In the second example for dot product, we have the following example of finding angles. So let A, B, C be those three corners that we see down there, and then they want us to find the angle between between vector AB and vector BC. So I think the first step is going to be quite simple, right? First, find the vectors AB and BC. So vector AB, simply 2 to 1 is -1, 4 to 3 is -1, 1 to 2 is 1. Alright, so this is what I did. Of course, you can do OB minus OA or 1, 3, 2 minus 2, 4, 1. That will work as well. But I do it this way because, again, keeping with the very basic definition of vectors is going one point to the other. BC 1 to 4 is 3, 3 to 6 is 3, 2 to 3 is 1. Quite simple. So why does a dot product work here, and how how can we use the dot product to find the angle between the two vectors? If we recall from the dot product, we have A dot B equals to mod A, magnitude of vector B, cosine theta. A dot B, well, if you recall, if we recall from A dot B, it will give us a real number, right? It's A1, B1 plus A2, B2 plus A3, B3. So this gives us a real number. Mod A, mod B, they are real numbers. So eventually get cosine theta equals to a real number. And then we can take the inverse to find the angle. And just, well, usually theta is in angles, or is rather, I mean, it's in degrees. What am I talking about? All right. So how to use the dot product here? Simply, we start off with -1, -1, 1.331 over magnitude of A. So it's simply -1, -1, 1. So each of them squared, root 3. 331, so it comes 991, 19 equals to cosine theta. Working that out, it gives us cosine theta equals to, or actually let's do it, skip more steps. Theta equals to cosine inverse on top, -3 minus 3 plus 1. So -6 plus 1 minus 5 over 3 times 19 is simply root 57. So using the calculator, that would give us, let's see, 131.47 degrees. Let's count the approximate sign. Equals to 131.5 degrees. All right. So again, when it comes to angles, 1 decimal place. So that is how we can use the dot product to find the angle between two vectors. Now you notice that this gives us an obtuse angle because the dot product gives us a negative value. But if, let's say for example, or rather, if we want to find the acute angle instead, then we would apply a modulus, right? So the trick is A dot B, mod A mod B gives us the angle. All right. So this theta is acute or obtuse. But if we were to, let's say, add a modulus to it, then we know that this particular value will always be positive, right? This one would be always positive. And because of that, cosine theta is positive. This would then only be acute. All right, so if they want to find the acute, we must add the modulus sign, all right? So this is how we can use a dot product to find the angle or the acute angle between two lines, two vectors, or soon enough, a line and a plane, and as well as two planes.